In this video, we're going to focus on naming coordination compounds. So let's start with this example. CO, NH3, 6, Cl2. So how can we name this particular coordination compound? So what you need to realize is that the first part represents the cation. The second part is the anion, which carries the negative charge. Now first, we're going to go over a few examples where the cation is the complex ion. Now one of the first things I like to do is identify the oxidation state of cobalt. So let's write an equation. We have cobalt, 6 ammonia molecules, and 2 chlorine atoms, or in this case, ions. Now I'm going to replace cobalt with X because we want to calculate the oxidation state of that. NH3 is neutral, so I'm going to replace it with 0. In this case, the oxidation state of the chloride ion is -1. And the net charge of a coordination compound is always going to be 0. 6 times 0 is 0. 2 times -1 is -2. And so we have x minus 2 is equal to 0. And if we add 2 to both sides, x is equal to 2. So the oxidation state of cobalt is 2+. So the complex ion is going to be CO NH3 with a 2+ charge. And then the anions are chloride. So the first thing we need to name is the cation, in this case the complex ion. So we have 6 ammonia molecules. 6 stands for hexa. And then the ligand is an amine. But when you name it, you need to use 2 M's as opposed to 1. So this is going to be hexaamine. And then we need to name the transition metal, cobalt, and then the oxidation state, which is 2. So the name of the complex ion is hexaamine cobalt 2. And then we can name the anion, which we're going to use an IDE ending. So that's simply going to be chloride. And so that's how you can name this particular coordination compound, hexaamine cobalt 2 chloride. Now let's move on to our next example. You can pause the video and try this one. So what is the name of this particular complex or coordination compound rather? Once again, let's calculate the oxidation state. So we have CO, 5 NH3 molecules, and 3 chlorine particles. Now ammonia has an oxidation state of 0. Chlorine is -1. And so it's going to be x minus 3 is equal to 0, so x is 3. So the oxidation state of cobalt is +3. Now let's go ahead and name it. So let's start with the complex ion first. So we have 5 NH3 molecules, so 5 stands for penta. So it's going to be pentaamine with 2 M's. And then we have a chlorine that's part of the complex ion. So we're going to call that chloro. And A comes before C, so we need to put it in alphabetical order. And then after that, it's going to be cobalt with an oxidation state of 3. And then we can leave a space. And then for the anion, we're just going to say chloride. So it's pentaamine chlorocobalt 3 chloride. Now let's move on to our third example. Go ahead and try that one. So once again, the complex ion is the cation. Now let's determine the oxidation state first. The oxidation state of water is 0. And for bromide, it's -1. But there's 3 of them. So this is going to be -3, which means cobalt has to have an oxidation state of +3. If you don't like that method of doing things, you can write the equation to get the answer. Now let's start by naming the complex ion, or the cation. So what is the prefix for water? What's the name for it? When dealing with water, you need to use the word aqua. and there's 6 of them, so it's going to be hexa, aqua, aqua means water, cobalt with an oxidation state of 3, and then the anion is bromide. So instead of saying bromine, just replace the INE with IDE. So it's hexa, aqua, cobalt, 3, well, I put bromine. This was supposed to be bromide. Hexa, aqua, cobalt, 3, bromide. Let's try this one. K3FeCN6. So this time, notice that the anion is the complex ion. So the naming is going to be a little bit different in this example. But first, let's calculate the oxidation state of Fe. So we have 3 potassium atoms, or ions, and then we have Fe and 6 cyanide ions. Now the charge on potassium is going to be +1, and for cyanide, it's -1. So this is 3, and then this is -6. So we can combine like terms. 3 minus 6 is -3. And then if we add 3 to both sides, we can see that the oxidation state of Fe is +3, or 3+. So now that we have the oxidation state, how can we name it? The first thing you should do is name the cation, and you just got to name the element. So the element K is potassium. So next, name the complex ion. So we have 6 ligands, so it's going to be hexa, and for cyanide as a ligand, you would call it cyano. And then to name Fe, you won't say iron, but you have to use the Latin name. So you would say ferrate, and then the oxidation state, which is 3. So it's potassium hexacyano ferrate 3. Now let's move on to the next example. K3COF6. So once again, the second one is the complex ion. So first, let's name K. K is potassium. And let's identify the oxidation state. Potassium has a +1 charge. Fluorine has a -1 charge. 1 times 3 is 3. -1 times 6 is -6. Now cobalt has to have a +3 charge, so that these 3 numbers add up to 0. So once again, we have the cobalt 3+ ion. Now let's go ahead and name the complex ion. So we have 6 ligands, therefore this is going to be hexa, and the ligand is fluorine, so we're going to call it fluoro, and then the Latin name of cobalt, which is cobaltate, and then the oxidation state 3. So it's called potassium hexafluoro cobaltate 3. Now let's try one more example. And instead of using K, let's use Na. So Na4PtCl6. Feel free to pause the video and try this. Sodium has a +1 charge. Chlorine has a -1 charge. So this is going to be +4, -6, and for these numbers to add up to 0, platinum has to be +2. So now that we know the oxidation state of platinum, let's name it. So Na is called sodium, and now let's name the complex ion, or the complex anion. We have 6 chlorine atoms, so it's going to be hexa, chloro, and then the Latin name for platinum, that's going to be platinate, with an oxidation state of 2. So it's called sodium hexachloroplatinate. Now, just in case you encounter these elements, you need to know the Latin name for it. So if you see Cu, the Latin name is cuprate. And if you see Sn, stanate. Now, what do you think the Latin names for these elements are? Pb, lead, gold, and silver. So for lead, it's going to be plumbate. Au, aurate, and Ag, argentate. And so those are some other Latin names for other elements that you may encounter. So that's it for this video. Hopefully it gave you a good understanding on how to name coordination compounds. Thanks for watching.